All right, so this lesson is on the quadratic formula. And so before we use the quadratic formula, we have to review how to simplify square roots. And so square root of 64, that is actually a perfect square. 8 squared gives you 64. And so the square root of 64 is just 8. If you were to make a factor tree for that, you would have nothing left under the radical. And so, for example, you would do 2 and 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2. Okay, and so when you make your radical, you have a pair of 2's, you have another pair of 2's, and you have another pair of 2's, and nobody gets left behind. So your radical is not necessary, and 2 times 2 is 4, times 2 is 8. And so anytime you realize your radical isn't necessary, it means you were dealing with a perfect square. Okay, 48 is not a perfect square. So 2 times 24, 2 times 12, 2 times 6, 2 times 3. Those are all our prime factors. And so when I make my radical, we've got a pair of 2's, we've got a pair of 2's, and we have a lonely 3 left behind. And so this simplifies to 4 square roots of 3 for our final answer. Right? And now this is what we're going to have to simplify later. And so we're going to start by simplifying this square root of 76. So that would be 2 and 38, 2 and 19 is prime. And so we have a pair of 2's and then a 19 that stays behind. And so you could rewrite this as -6 plus or minus 2 square roots of 19 all over 2. And then you can break up the plus or minus and simplify them individually. So -6 over 2 is -3. And then here, the 2's would cancel, leaving me just square root of 19. All right. And so the quadratic formula, this is kind of a rhyme, so you can help remember it. But the important thing is you have to make sure your quadratic equation is set up with everything on the left-hand side in order, ax squared plus bx plus c. That way you can identify what a, b, and c are. Because the quadratic formula, I'm going to sing the song because I always remember the song. Using those a, b, and c values, it's x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. And so we're going to plug in values for the b. We're going to plug in the a value here. And we're going to plug in the c value here. Okay? And so we're just going to practice that. Let's skip to number 3. Okay? So this one's already set up. And so we are ready to identify our a value, our b value, and our c value. And so our a is 3, b is 5, and c is -8. So after I identify my a, b, and c, I sing the song, x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. Right? And so x equals negative, and then our b value is 5. Plus or minus the square root of b squared. And so b, I always put in parentheses, squared, minus 4, and then our a value is 3, and then our c value, I guess I'll use that, is negative 8. All over 2 times our a value, which is 3. Okay, and so once I get everything plugged in, we can use our calculator, which for us is Desmos, and start number crunching. Okay, and so I go ahead and leave part of it. So x equals, I'm going to leave that negative 5 out front. I'm going to leave the plus or minus. And then I simplify everything under the radical and type it in parentheses. So everything under the radical, don't even type the radical. And type it exactly how it looks. Okay, it gives us 121. And then 2 times 3 is 6. Okay, and so now, let me highlight that. We've just typed all that into the calculator and got 121. And so now we need to simplify that radical. And 121 is actually a perfect square. It gives us 11. And so I can simplify that even further to negative 5 plus or minus 11, no more square root, all over 6. Okay, and so now that I have all whole numbers here, we can actually break this up into the plus or minus case. And so one case has the negative 5 plus 11 over 6. The other case has the negative 5 minus 11 over 6. Okay, and so negative 5 plus 11 over 6 is 1, and negative 5 minus 11, I'm just going to delete the plus and put a minus, is a fraction, negative 8/3. And so those would be our solutions. Okay, for number 2, we're not set up yet. We need to move this 16 to the other side. Since it's negative, we're going to add it. And so that gives us x squared minus 8x plus 16 equals 0. Okay, and so my a value is 1. My b value is negative 8. And my c value is positive 16. Okay, and so x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. All right, so our b value this time is negative 8. And the reason why I sing opposite b, because negative 8 is just positive 8. And so instead of writing negative 8, I'm just going to write positive 8. Plus or minus the square root of b squared minus 4ac. So b is 8, a is 1, and c is 16. All over 2a. Okay, and so now we're going to number crunch in the calculator everything that's under the radical. Don't type the radical. So 8 squared, minus 4ac. Okay, we get a 0. So I've got 8 plus or minus, oh, that was technically negative 8 squared, but when you square it, it becomes positive. So still 0. And so square root of 0 all over, and 2 times 1 is 2. So when you add the square root of 0, the plus or minus 0 doesn't affect anything. The square root of 0 is just 0. So 8 over 2 is our only solution, which is 4. And so this is one of those cases, and I'll actually just type it in for you to graph it, where we only have one solution. 4. And so x equals 4 is our only solution. Okay, we could have also graphed the last one too, just reminding you that this is just another way to solve, mostly when you don't have Desmos or a graphing calculator. But we can check number 1, 3x squared plus 5x minus 8. Solutions are that decimal, negative 2.6 repeating, and 1. And so we got the negative 2.6 repeating. You can convert that to a fraction by continuously typing that 6 until the fraction goes away and comes back negative 8/3. Okay, we're going to keep practicing with the quadratic formula, because in Algebra 2, when you start getting imaginary solutions, Desmos will not help. Right, so same drill, we need to move this 5x and this 104. Since they're both negative, they're going to be positive on the other side. Okay, and so our a value is 1, our b value is 5, and our c value is 104. That's pretty ugly. So I'm going to go ahead and type this in and see what it looks like. Okay, so this one looks like it doesn't ever cross the axis, the x-axis. So this would be a no solution case. And I'll show you what happens when we try to use the quadratic formula. All right, so x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. So x equals opposite b plus or minus the square root of b squared minus 4a c. All over 2a. A. Okay, and so when I try to simplify the expression under the radical, we get a negative number. The expression under the radical actually has a special name called the discriminant. Whenever your discriminant is negative, it kind of tells you there's no solution. Okay, so we have x equals -5 plus or minus the square root of -391. All over, and 2 times 1 is 2. Okay, and so when I try to type the square root of -391, undefined. Okay, and so when you get that undefined, it's because you can't square root a negative number. So our solutions are actually imaginary. And so for Algebra 1, we just say no real solution. The solutions are imaginary, and you'll calculate those in Algebra 2. All right, for this one, I'm just gonna set it up and then let you check the keys so I'm not singing to you for this whole thing. Okay, and so here we would need to move this 8 to the other side, and it can actually combine with the 26. So x squared minus 10x, and then 26 minus 8 is 18. And so you would use the quadratic formula with a equals 1, b equals -10, and c equals 18. Over here, we would need to subtract the 23, and it doesn't combine with anything. And so here your a value is -1, your b value is +10, and your c value is -23. And so that's how you would use the quadratic formula. Here you would need to add 6x, and it would go right in the middle. Don't combine it with anything. There's no other x terms. And then your a value would be 1, your b value would be +6, and your c value would be -59. So I'll let you try all these with the quadratic formula and check your answers.